Hello everyone, welcome back to Algebra 1 with Miss Betsy. We're going to be continuing our discussion of working with inequalities today, and we're going to be talking about our first two properties of inequality, which are the addition and the subtraction properties of inequality. I'm using as my text this book right here. It is Algebra 1 for Christian Schools, and it's published by Bob Jones University Press. This video is driven off of the second edition. Third edition contains the same material, it's just structured a little bit differently and in different orders. You can still use the video to your advantage, however. So let's go ahead and pray, see if I can find a lame joke, and we'll get started. God, I thank you for another day of life, and I thank you for the opportunity that we've had this morning to spend time worshiping together with those who love you as well. Father, I ask that you would help us today to be diligent, to pay attention to those things that you'd have us to do, and to do our best to honor and to glorify you in all that we do. And I pray in the name of your Son, Jesus. Amen. Okay, this book here is called Animal Jokes to Tickle Your Funny Bone, and I'm thinking that some people have a very different funny bone than I do. However, I do have one that I was able to select from this. And this said, why did the chicken cross, not the road, but why did the chicken cross the basketball court? Well, the reason for that is he heard the ref calling fouls. And of course, fouls that we are talking about here is the feathered kind. So the ref is calling fouls, and the chicken, smart bird that she is, crossed the basketball court. This is another section that's going to be very easy for you to deal with. It's a nice break after those difficult word problems you had. We're continuing on, and we've learned that inequalities are different from equations because equations, you have both sides of the equal sign have the same exact value. Inequalities, however, are statements that are not equal. 5 is less than 7. 2 is greater than equal or equal to a negative 4. It's not like saying 2 plus 6 is equal to 8. You have the same value on both sides of the equation there, but here we have differing values. And this is what inequalities are. And we're going to have, however, inequalities that we have to be able to solve and find the value of x for. So we're going to have to know, well, how do we deal with inequality symbols? Less than, greater than or equal to, greater than, less than or equal to, and not equal to. What rules do we have in place that will allow us to be able to solve for a variable here? So let's just play a game of what if right now. We know that it's true that 5 is less than 7. Well, what if we were to add 2 to both sides of that inequality? Would we still have a true statement? Yes. We still have a true statement there. You know, we start off with one number less than the other. As long as we add the same quantity to both sides of that inequality, the inequality remains true. Well, right here we've got a different inequality symbol. What if we say 2 plus 7, is that greater than or equal to a negative 4 plus 7? Well, let's just go ahead and add both sides, the same quantity to both sides of this inequality. And we see that we have 9 is greater than or equal to not 11, which is what I saw first. I thought, okay, we've got a problem here. We have a negative 4 plus 7, which of course gives us 9 is greater than or equal to 3, which is still a true statement. Well, what about up here? 6 is not equal to a negative 2, and if anybody doesn't understand that, then we have a little bit of a problem. If we add 3 to both sides of that inequality, is it true that we still have not equal to? Well, yes, of course. 9 is not equal to 1. So that's a true statement. So what we're seeing here with these three examples that I've stepped through is that it would tend to make you think that it would be true that when you're adding with inequalities, if you add the same quantity to both sides of that inequality, that the inequality is still true, just like with the addition property of equality. If you add the same quantity to both sides of the equation is still true. And we see that, it's been proved in math that yes, that property is exactly true for inequalities also. If you have an inequality that's out of balance this way, you add the same quantity to both sides of that equation. It doesn't say all of a sudden it's equal or all of a sudden it's greater than, but it stays out of balance in the same direction. The left-hand amount here is still going to be smaller than the right-hand amount. The quantity on the left here is still going to be greater than or equal to the quantity on the right-hand side, regardless of what you add. And that's what we call the subtraction property of inequality. The addition property of inequality, and I'll write that out for you in a moment. Now, I spoke subtraction property of inequality, so let's go ahead and do some subtraction. What if we subtract 3 from both sides of this inequality? Are we still going to end up with a true statement? Negative 9 minus 3 gives us a negative 12. Is negative 12 less than or equal to a negative 6? Sure, of course it is. Negative 12 is further to the left on the number line. Negative 12 is less than or equal to a negative 6. And what about here when we have 2 greater than 0? What if we subtract an 8 from both sides of that inequality? 0 minus 8. Is it still going to be true that the left-hand side of this inequality, that's supposed to be an 8, is greater than the right-hand side of the inequality? Yes, that's true. Negative 6 is greater than a negative 8. Remember, negative 6 is further to the right on the number line, and it's greater. So what I have illustrated for you right now on this whiteboard is what we call the addition and subtraction property of inequality. Let me just go ahead and write one of them. But you need to know what these properties are. The addition property of inequality. And this says that A, B, and C are real numbers. Okay? They're just any number you want to think of that's a real number. And if A is less than B, then A plus C is still going to be less than B plus C. This is the addition property of inequality. This tells us that regardless of whatever this inequality symbol is, less than, greater than, not equal to, less than or equal to, greater than or equal to, if you add the same quantity here represented by C, if you add the same quantity to both sides of that equation, of that inequality, the truth of the inequality does not change. So this is the addition property of inequality. We adapt it just a tiny little bit, and we can say that it is the subtraction property of inequality. Then you have the same thing. A, B, and C have to be real numbers. A has to be less than B, but you're going to have A minus C is still going to be less than B minus C. So, what we have seen right now is that we have distinct, not similarities, but exact same way that you deal with inequalities and equations when we are talking about subtraction and addition. Doesn't matter if you have an equation which has the equal sign, or if you have an inequality, which includes one of those 5 inequality signs that we talked about: greater than or equal to, less than or equal to, greater than, less than, or not equal to. If you have an inequality, you have the truth of the statement that you can add the same quantity to both sides of that inequality, or you may subtract the same thing from both sides of that inequality, and the inequality itself is still true. So that's what 5.2 is about. It's very, very, very straightforward. So let me do just one quick example from section A, because this says solve each inequality, graph some of them, numbers 1 through 5, on a number line. Let me just go ahead and graph, let me do number 2 and number 4. For number 2, this is on page 187. We have x minus 2 is less than or equal to 3. And then we have, for number 4, z plus 1 is not equal to a negative 2. So we're going to treat these, for solving them, just as though they were equations. We want to isolate the variable by adding a 2 to both sides of the inequality. And now we have that x is less than or equal to 5. This is our solution to the inequality. X can be any number, any one of an infinite number of values, as long as x is no greater than 5. It can be 5 itself, but it cannot be greater than 5. And we remember that the way that you graph this, because x can have a value that is equal to 5, we're going to have a solid dot on 5, and we're going to shade everything to the left of that number line. This right here tells us that x is less than or equal to 5. Now we have z plus 1 is not equal to a negative 2. In order to be able to isolate that z, we are going to subtract 1 from both sides of this inequality. Negative 2 minus 1, and I have z is not equal to a negative 3. Z is not equal to a negative 3. How are we going to graph this? Remember, this is sort of the special case here. I have a 0, I've got a negative 3, I've got a 3. What is a part of the solution here? Well, it says z not equal to negative 3 means everything in the world except for negative 3 is part of the solution. And because negative 3 itself is not a part of the solution, you make an open circle on that, and then you shade in the number line on both sides of that open circle. This is all that you do to solve inequalities that involve addition and subtraction. Let me just pick one that maybe you think might be hard, and it's not. It's really not even necessary to watch this one. This is problem number 22, but I'm going to distribute. So even though I said you shouldn't watch, you still should. This is number 22. 2 times the quantity y plus 5 is less than y. We only have addition going on. We do have to distribute a 2. 2 times y plus 2 times 5. 2y plus 10 is less than y. Now what do we have to do? We have y's on both sides of the equation. We don't want that. So let's go ahead and collect our y's on the left-hand side of the equation. And in order to be able to do that, we're going to have to subtract the y from both sides. 2y minus y plus 10 is less than y minus y. What do I have now? negative y. Negative y, positive 2. 2y minus 1y is a positive y, isn't it? So we have y plus 10 is less, y plus 10, come on hand, is less than 0. We subtract a 10 from both sides of this inequality, and we have that y is less than a negative 10. Okay, let me verify since I want to see if they're having us graph it. They're not having us graph it. How would you graph it? You would have an open circle at negative 10, and you would shade everything going to the left. Now, let me do problem number 22 next. And let's talk about this one. Problem 22 says, that was 22. Well, let me just show you 24. 4x plus 5 minus the quantity x plus 7 greater than 2 times the quantity x minus 3. Now, let's step back and make sure I got this copied. 4x plus 5 minus the quantity x plus 7 greater than 2 times x minus 3. Treat this just as though it's an equation. We're going to have to distribute the negative 1. We're going to have to distribute the 2. 4x plus 5. What happens when we take negative 1 times a collection of terms within inside the parentheses? The signs of those terms are going to switch because we're saying negative 1 times positive x becomes negative x minus 7. Everybody see that? This right here is a huge difficulty. We forget when we're distributing a negative that the sign of every term inside those parentheses changes. Now we have greater than 2 times x minus 2 times 3, which is 6. Just treat this as though it were just a standard equation. We're going to collect like terms. 3x minus 2 is greater than 2x minus 6. And when we complete this, we should have x is greater than a negative 4. We have x is greater than a negative 4. If we were graphing it, we would have an open circle at negative 4. Everything to the right would be shaded in because that is a part of the solution. So all you have on this. This is a very, very, very easy gift homework section too. You should take you no time at all. But if you get stuck, text me or I will see you on Friday.